Chapter 3, Section 1 is about matrices. We are starting new chapter. Um, when we just look at one number, it's not a problem. If we just have one piece of data, it's not a big deal to look at it and analyze it. But what happens when we have lots of information that you want to look at it all at once? So when there is a data or information, we can convert those data and information into a matrix. So matrix is a rectangular array of numbers enclosed in brackets. So we use a bracket similar to the square bracket. For example, here we see a data given and information given. And we put these numbers, the information given in this table, into the matrix by using a square bracket and writing down every number that we have here inside this bracket in order. So when we look at these values, the numbers horizontally, we call them as row. We have row 1, row 2, and when we look at the numbers vertically, they are columns. Column 1, column 2, column 3. So there are a lot of different aspects of matrices. I want to introduce some of them now. First, we need to know the row and column, and then we have to talk about dimensions. Whenever we have a matrix, we have to talk about its dimensions. So dimension means what's the size of it? What by what? How many rows, how many columns do we have? For example, for the given matrix, we have 1, 2 rows, 1, 2, 3 columns. So we say this matrix is 2 by 3 matrix. So we write this as 2 multiplied by 3. So matrix A has 2 rows and 3 columns. So it is 2 by 3 matrix. There's another thing we need to talk about. It is the entry. Entry is the elements, the values that's given in the matrix. So here we have 1, 2, 3, 4, 5, 6 entries. So those numbers are all called entry. Let's move on with address. As the name refers, address of an entry is its location in the matrix. So this location is given by lowercase letter. If the name of the matrix is A, capital letter A, the address is lowercase letter a, and first we write the number of rows, location of the row, and then location of the column. So when expressing the dimension of the matrix, number of rows always comes first. So we read this as A sub 2 by 1. A sub 2 by 1. So address is an entry. Address of an entry is its location in a matrix expressed by using the lowercase matrix letter with the row and the column number as subscript. So here is the address of this address of this number. Let's take a look at the question and revise all of the elements that we talked so far: dimension, entry, address. So first one, we are given a matrix M. By using the matrix, let's answer the questions. 1a, what are the dimensions? Dimensions means the number of rows and the number of columns. So how many rows do you see here? 1, 2, 3 rows. So there is 3. How many columns? 1, 2, 3, 4 columns. So horizontally we have 3 rows, 3 set of numbers. Vertically we have 4 sets of numbers. So it is 3 by 4. What is the entry at M sub 3, 2? That 3 corresponds the location of row. That 2 corresponds location of column. So at the third row, this means we are in the third row and the second column. Third row, here in the last row, and the second column, first, second. So here is our number. So that entry corresponds number 11. Another question, the entry 0 appears at what two addresses? We have two zeros here. What is the address of first zero? So what is the location of this column? Which which row is this? This is the first row. So it is first. And which column is this? First, second, third, fourth column. So first row, fourth column. The name of this matrix is M, capital little m. The address is expressed by lowercase little m. So address of 0 here is m sub 1 4. Another 0, the other 0, m sub, what's the location of the row? It's in the 1 2 second row. So write 2 here. And which column is this? 1 2 3 in the third column. So m sub 2 3 is the address of another 0 here. Let's move on. Now we are going to talk about equivalent matrices. So if two matrices are equal to each other, then their corresponding entries are equal to each other. So we need to find x and y. So where do we have x on the left? On the left, we have x here in the second entry. So what is the corresponding entry? This is the corresponding entry. They are supposed to be equal to each other since they are equal matrices. So write negative 2x equals negative 15. I need x alone. Divide both sides by negative 2. X becomes 15 over 2, which is 7.5. What about y? For y, we see y here in the second row and the second column. The corresponding entry here is this in the second matrix, and they're supposed to be equal to each other. Equalize them. 3y equals negative 2y plus 15. Move 2y to the other side. 5y is 15. Dividing both sides by 5, y will become 3. So we got the value of y as 3, and we also got the value of x as 7.5. This is pretty easy. Let's move on. There is another thing we need to talk about in matrices. It's how we add and subtract. So adding and subtracting matrices is pretty easy and simple. So when we add and subtract, first of all, we have to make sure that matrices have same dimensions. If their sizes are same, then we can easily add or subtract. So when we add or subtract, all we have to do is add or subtract the corresponding entries. So those two corresponds and these two correspond. So when we add first entry is first, 1 plus 5 as 6, and second entries together, 2 plus 10, 12, like this. So we can do this only when we have same dimensions. For example, look at these two matrices. We have 2 by 2 matrix here. Here also 2 by 2. Here 3 by 1, 3 by 1. Their dimensions are same, so we can add corresponding entries. Here they correspond each other, so we can add them up. But here in these two examples, they don't have the same dimensions and they don't have the corresponding entries. So where do I add 1 to? There is no first row, first column. There is no first row, second column. There is only one column here. So we can't add them. They are not compatible for adding. So it's not like numbers. Matrices are not like numbers. We can't add every matrix. In order for them to be added or subtracted, we have to make sure that they have same size. Let's take a look at an example. Check it out. 3, it's asking about adding or subtracting, if it is possible. So b plus d. B plus D. The first question is it compatible for adding? So check dimensions. Here we see two columns, three rows, two columns, three rows. 2 by 3 matrix is B. Matrix D is also 2 by 3. So since they have the same dimensions, we can add them. So it is possible to add B and D. So when you add B and D, you are going to add corresponding entries. 4 plus 0, which is 4. Negative 1 plus 1, which is 0. Negative 5 plus negative 3, which is negative 8. We are done with the first row. Do the same for the second row. 3 and 3 corresponds. 3 plus 3 is 6. 2 and 0 corresponds, which is 2. 8 and 10 are in the same entries, same locations. We add them up. We got 18. So this is the result of adding these two matrices. What about B minus A? B minus A. The dimension of B is 2 by 3. Dimension of A is, we have 1, 2, 3 rows and 2 columns. 2 by 3 is not same as 3 by 2, so they are not compatible for adding. So it's not possible. We say not possible or not compatible for adding. What about subtraction? Subtraction works the same way. D minus B. We already checked their dimensions. Since they are same, we can do the subtraction. So let's do the subtraction then. D minus B. Be careful. B minus D is different than D minus B. So D, 0 minus 4, which is minus 4. 1 minus minus 1, which is 2. Negative 3 minus minus 5, which is also 2. We are done with the first row. Second row, 3 minus 3, 0. 0 minus 2, negative 2. 10 minus 8, 2. So this is the result of this subtraction. So we just have to subtract corresponding entries. When there is addition, add corresponding entries. So there's one more subtitle in this section, simplifying matrix expressions. We can multiply any matrix by any number. This number is called a scalar, so we can do the scalar multiplication. When we multiply a matrix with any number, we multiply that number by every entry in the matrix. For example, in check it out 5, the first one says find 2b plus 3c. If it is possible, is it possible? The first question is it possible to do the addition or subtraction? Before we try adding them, we have to figure out if it is compatible for adding or subtracting. B plus C. The dimensions of B is, we have 2 rows, 3 columns, 2 by 3. Dimensions of C is 2 rows, 2 column, 2 by 2. 2 by 3 is different than 2 by 2, so we can't do this addition. So it is not compatible for adding. Matrix B and C are not compatible for adding, so it's not possible. Part A is not possible. What about part B? A and C. Dimensions of A, we have 2 rows, 2 columns, so 2 by 2. C is also 2 by 2. They have the same size, so yes, it is possible. We can do the subtraction. But first of all, we need to figure out what 4a is. So first multiply a by 4. 4a means 4 multiplied by matrix A. 4, negative 2, negative 3, 10. And all we have to do is distribute this 4 into the matrix for every entry. 4 by 4 makes 16. 4 by negative 2, negative 8. 4 by negative 3, negative 12. 4 by 10, 40. We got 4a. Now let's derive 3c. Multiply c by 3. 3 multiplied by matrix C, which is 3, 2, 0, negative 9. So similarly, we multiply every single entry in this matrix by 3. 3 by 3 makes 9. 3 by 2, 6. 3 by 0, 0. 3 by negative 9, negative 27. Now we got 4a and 3c. Now we have to subtract them. 4a minus 3c equals, let me write down the matrices again. 4a matrix is 16, negative 8, negative 12, 40, and 3c matrix is 9, 6, 0, negative 27. Now subtract the corresponding entries. 16 minus 9 gives you 7. Negative 8 minus 6 gives you negative 14. We are done with the first row. Second row, negative 12 minus 0, negative 12. 40 minus negative 20 minus 27. You add them up because minus minus makes plus. It gives you 67. So this is your resultant matrix.